action. This question is from the textbook and from our homework, 828, page 404. And in this question, it asks the following. In the figure at the right, or the following figure, PQ equals RS. So the given PQ, I'm going to put a bubble in for PQ, equals RS, and that is given. It also says that PR equals SQ. So that's easy. We just write PR equals SQ. Write given. Make sure you write given. And it says prove that angle P is, I'm going to put this down here. We want to prove that. Prove angle P is congruent to angle S. So that's our end point. That's what we're looking for. That's what we're trying to get. We're trying to prove that angle P is congruent to triangle S, and that would mean intuitively angle P, angle S. So first of all, again, the tactic for proofs is to first get an intuitive feeling for it and put all the information down on the diagram. So PQ equals RS. I'm just going to put a slash there and there to indicate that those two are equal. PR equals SQ. I'm going to put a slash, a double slash there, and a double slash here to indicate those two lines are equal. And so we have SS. I'm getting my kind of intuitive feeling here. I'm going to go for a third bubble. I don't know what it is yet. All three of those are going to lead to proving thou. Because I'm asked to prove that a part of these two triangles are congruent, I'm thinking that maybe I need, first of all, to prove that the triangles themselves are congruent. Because if I do, if I prove that these two triangles are congruent, that would be PQR and SRQ. If I prove those two congruent, then by CPCTC, I will have angle P and angle S congruent. So I'm going to try to prove these two triangles are congruent, and I already have S and S. Okay, I've got S, and I can do that without my pencil leaving or my pen leaving the paper, S, S. And what happens if I have this one congruent to itself? Well, guess what? It is a shared side. And look at this. I'm going to make that the third one because QR equals QR, shared side. And I also put reflexive. Okay? Reflexive property. Okay? It's a reflection of itself. That's one way to think about it. And there we go. And what theorem is that? It's triangle PQR is congruent to triangle SRQ, and it is by SSS. Very good. By the SSS theorem. Now I don't need to prove it anymore. I can just say that this is true. CPCTC, and I'm done. Guess what? Okay, so again, CPCTC stands for corresponding parts of congruent triangles are congruent. And that's exactly what we need to be able to prove that angle P is congruent to angle S. Again, corresponding parts of congruent triangles are congruent. CPCTC. And all right, so this is a good point from one of the questions is, what is this TR? Well, actually, this TR doesn't come into play. It's just the line crossing over the triangle. So what this is, I've shaded this in a little darker. SQR is, as you can see, the triangle here, and then we have another triangle there. I'll just shade it in a little darker so that you see that that is why the QR is the shared side. And really, these two segments don't come into play in this proof at all. Any other questions?